Hello, welcome to this lecture on 3D geometry. I'm Dr. Chandra Vaidyanathan. I have my master's in applied mathematics from University of Notre Dame. I also have a PhD in pure mathematics from University of Missouri, Columbia. I'm today representing Global Institute of Innovation and Entrepreneurship. You can visit www.globaliie.com for more information about the Global Institute of Innovation and Entrepreneurship. Today's lecture will be about planes. We'll begin with a brief review of equation of planes. So we'll start with the most general form of the equation of a plane, which is ax plus by plus cz plus d equal to 0. This is the most general form of a plane. We also have the equation of a plane passing through a point. It is a times x minus x1 plus b times y minus y1 plus c times z minus z1 equal to 0, where a, b, and c are the direction ratios of the normal to the plane, and the plane passes through the point x1, y1, z1. Now the intercept form of the plane is x by x1 plus y by y1 plus z by z1 equals 1. We also have the normal form of a plane, which is of the form lx plus my plus nz equals p, where p is the length of the perpendicular from the origin and l, m, and n are the direction cosines. Now we say that two planes, a1x plus b1y plus c1z plus d1 equal to 0, and a2x plus b2y plus c2z plus d2 equal to 0. These two planes are going to be perpendicular if the dot product between the coefficients is equal to 0. So a1 times a2 plus b1 times b2 plus c1 times c2 is equal to 0. And they're said to be parallel if I have a1 by a2 equals b1 by b2 equals c1 by c2 equals some constant. Right? And then finally, if I have two planes intersecting in a line, and I want the equation of the plane which contains this line, the easiest way to find the equation of this new plane is to set up p1 plus lambda times p2 equal to 0.
Yeah.
And finally, the length of a perpendicular from a point to the plane ax plus by plus cz plus d equal to 0 is given by p equals ax1 plus by1 plus cz1 plus d over square root of a squared plus b squared plus c squared, where x1, y1, z1 is the point from which we are dropping the perpendicular. Fine?
Yeah.
Is that fine? That's a brief review of the things that we need to do, the problems for today.
Yeah.
Okay, so we'll start with the problems now.
Yeah.
All right, so here is problem number 1. This is from the JEE mains. So find the value of k such that x minus 4 by 1 equals y minus 2 by 1 equals z minus k by 2. This lies in the plane 2x minus 4y plus z equals 7. So they're saying what they've given here is the symmetric form of a line. So this is a line in 3 dimensions. This line lies in the plane 2x minus 4y plus z equals 7 if k is of a particular value. And what we want to find is if k is equal to 7 or k is equal to minus 7, if there is no real value of k for which this line is going to lie on this plane, or k is equal to 4. These are the 4 options given. All right. So, have you understood the problem?
Yeah.
So we'll discuss the strategy to solve this problem. So how would you solve this? First, take a point on the given line. Right? This line is in symmetric form. So any point x will be of the form t. Suppose all of these ratios is equal to t, then any point x, y, z will be of the form x equals t plus 4. Do you see that? So I have here x minus 4 is equal to t, because the denominator here is 1, the denominator here is 1. So I have that x minus 4 is equal to t. So x minus 4 equals t, which means x equals t plus 4. Right? Similarly, I have y minus 2 here, and that is equal to t as well. So y minus 2 equals t, which means y equals t plus 2. And I have z minus k equals 2t, which means z equals 2t plus k. Are we okay with this? So x is of the form t plus 4, y is of the form t plus 2, z is of the form t plus k. If I set t equal to 0, set t equal to 0, I'll get x is equal to what? If I set t equal to 0, what will I get x? X is 4. If I set t equal to 0, y will be what? Here t is 0. So what will be y?
Yeah.
2.
Yeah.
And then if t equal to 0, z will be what?
Yeah.
A. All right. So
Yeah.
my one of the points on this line is 4, 2, and k. Fine. So the strategy for solving this problem will be all right. So the strategy will be okay. So take any point on the line. It will be in terms of k. As we saw, the point we found was 4, 2, k. It was in terms of k. And the next thing is, what do we have to do? Oops. The next thing is use the fact that 4 to k is on the plane as well to solve for k. So here is what the visualization of this will look like. We are going to have this plane here. Somehow if we chose k to be correctly, then the line that we have here is going to be on the plane itself. If not, the line can be projecting out anywhere that we want. You know, maybe it'll come like this. Maybe it'll project out like that. Maybe it'll project out like that. It's not going to be fully, if it's like this, that's great. But it may project out depending on the value of k. So this is the visualization of the problem, and we are asked to find k such that this line is going to be fully in this plane. So how do you go about solving it?
Okay.
Since the line lies in the plane, 4 to k must be in the plane as well. So that means I can plug in for x 4, I can plug in for y 2, and I can plug in for z k in the equation for the plane. So 2x minus 4y plus z equals 7. So if I do this, k is going to be equal to 7. That solves the problem, the first one. Fine? Any questions?
No.
Okay. Let's go for problem number 2.
Yeah.
This is from JEE Mains 2015. So you're told that the equation of the plane containing the line 2x minus 5y plus z equals 3 and x plus y plus 4z equals 5 and parallel to the plane x plus 3y plus 6z equals 1 is 2x plus 6y plus 12z equals 13, x plus 3y plus 6z equals minus 7, x plus 3y plus 6z equals 7, or 2x plus 6y plus 12z equals minus 13. So first of all, how do we understand this question? We are given that we need to find the equation of a plane which contains the line, and we are given two equations here. So what are these two equations? They are both equations of a plane. So really the line is given as the intersection of these two planes. When these two planes intersect, 2x minus 5y plus z equals 3 intersects with x plus y plus 4z equals 5, you get a line. And that line is contained in this plane, and it is also parallel to the plane x plus 3y plus 6z equals 1. So what might be a strategy to solve this problem? The strategy would be find a point that is on both the planes given, which means find a point on the line of intersection, and then use the fact that the required plane that we want passes through this point and is also parallel to another plane to find its equation. Right? So really, what is the situation here? If you want to visualize what is going on, we have two different planes, and as you can see here, there is this point of intersection. There is this point of intersection here. This what do you call the line of intersection? So if you can see here, there is this line of intersection, and once we have this line of intersection, we want another plane which has this line as part of the plane, and the plane also needs to be parallel to another plane which is given. So how do you go about doing this? There are two ways to do it. First is find a point that lies in both the planes that are intersecting. So to do that, I will let z equal to 0. I'll plug z equal to 0 into the first plane, which gives me 2x minus 5y equals 3. And I'll also have z equal to 0 in the second one. So that makes x plus y equals 5. Now I have to solve for 2x minus 5y equals 3. And I want to solve for x plus y equals 5. So how would I do that? X plus y equals 5, so I'll have y equals 5 minus x. I take this and plug it into the first equation, so 2x minus 5 times 5 minus x is equal to 0. So this gives me x equals 5 minus 5x equals 3, and that gives me x equals 4 and y equals If x is 4, y equals 5 minus 4, and y is equal to 1. Right? Now what do? I look at the point x, which is equal to 4, y equals 1, and z, which is equal to 0, and this point. So the plane is also parallel to x plus 3y plus 6z equals 1. So we get a1 by 1 plus b1 by 3 plus c1 by 6, where a1 x plus b1 y plus c1 z plus d1 equal to 0 is the equation of the new plane. Suppose I have that, like a1 x plus b1 y plus c1 z plus d1 equal to 0. If this is the equation of the new plane, it is also parallel to x plus 3y plus 6z equals 1. So the coefficients must be in the same ratio. a1 by 1 will be equal to b1 by 3, will be equal to c1 by 6, and all of those will be equal to the constant k. Fine. So once I have that, I can go ahead and evaluate what is k. I can find out what is k, because now a1 is equal to k, b1 is equal to 3k, c1 equals 6k. So I take this, plug it into my equation for the plane with z equal to 0 and x equals 4 and y equals 1. So what I get is a1, which is k, times 4 plus b1, which is 3k, times y. Y is going to be 1 plus d1 is equal to 0, because z is 0. I have just plugged in 4, 1, 0 into the equation for the plane.
Yeah.
All right. So now I'll go ahead and have this and find d1 in terms of k. So this gives me that d1 is equal to minus 7k. And if I plug in a1, b1, c1 and d1 in terms of k, I'll get a1 was nothing but k times 1. b1 was 3k, so plus 3 times x, so it will be x plus 3 times y, plus c1, which is 6k, so 6k times z, minus 7k, which is what I have for d1. This should be equal to 0. Since k is not equal to 0, I can remove this k out. Whatever is left over should be equal to 0. which gives x plus 3y plus 6z equals 7. That is the equation of the plane that I'm interested in. That is one way to do it. Right? Let's look at another way to do the same problem.
Yeah.
Here is the second solution.
Yeah.
Since I have the intersection of two planes, I have the first plane 2x minus 5y plus z minus 3. I have the second plane x plus y plus 4z minus 5. P1 plus lambda times P2 must be equal to 0. If I collect the terms with x, y, and z, I'll get 2 plus lambda times x and lambda minus 5 times y and 4 lambda plus 1 times z. So I can have these coefficients between the plane that I have here and the plane to which it is parallel, which is x plus 3y plus 6z. So I'm going to have 2 plus lambda times x plus lambda minus 5 times y plus 4 lambda plus 1 times z plus or minus of 5 lambda minus 3, and this whole thing should be equal to 0, which means 2 plus lambda by 1, 2 plus lambda by 1 plus, here is 2 plus lambda, which is the coefficient of x, and the coefficient of x here is 1. The coefficient of y is lambda minus 5. So lambda minus 5 by 3, which is the coefficient of y here. And I have 4 lambda plus 1, which is the coefficient of z. And here the coefficient of z is 6. So I should have that these ratios must be equal. Once I have that, what I can do is find what lambda is. So what I'll do, I'll go ahead and equate these two, so that 3 times 2 is 6 plus 3 lambda equals lambda minus 5. This gives me lambda equals minus 11 by 2. Once I find lambda here, I just have to go and put what is the value of lambda in the first equation, right? From here, I just have to put what is the value of lambda, and I'm done. And that's what I'll do here. So from here, I'll just take this value and put it here. Once I do that, I get x plus 3y plus 6z equals 7. Fine? So that is the equation of the plane. So we saw two ways to do the same problem. Next, problem 3. This is from 2012. We are given that the equation of a plane passing through the line of intersection of the planes x plus 2y plus 3z equals 2, and then other plane being x minus y plus z equals 3. This plane passes through this line of intersection, and it is at a distance of 2 by square root of 3 from the point 3, 1, minus 1. And we are asked what should be the equation of the plane, and we are given 4 choices. What would be the strategy to solve this type of a problem? So the strategy is very clear. First, form the equation of the new plane in terms of the parameter lambda. right? Because it is going to go through the intersection of two planes. Next, use the formula for the distance of a point from a plane to get lambda, right? So the visualization here is there are these two planes, they are intersecting on this line. There is a point somewhere there, maybe here, from which I drop a perpendicular, and I know what is the distance of the perpendicular from the point to the plane which is going to contain this line, and that is given to be 2 by square root of 3. I have to use that to solve. So what I'll do is I'll find the equation of the new plane that is going to be in terms of lambda. It is going to contain the line of intersection of two planes. So it is going to be the first plane plus lambda times the second plane, and that is equal to 0. So again, if I rearrange this in terms of coefficients of x collected together, coefficients of y collected together, coefficients of z collected together, then I'll get 1 plus lambda x plus 2 minus lambda y plus 3 plus lambda times z minus 2 times minus of 2 plus 3 lambda equal to 0. We are given that this plane here is at a distance of 2 by square root of 3 from the point 3, 1, minus 1. So all I have to do is plug in the distance formula. The distance formula is going to be 3 times 1 plus lambda plus 1 times 2 minus lambda minus 1 times 3 plus lambda minus of 2 plus 3 lambda, the absolute value of this, divided by square root of a squared, which is 1 plus lambda the whole squared, plus b squared, which is 2 minus lambda the whole squared, plus c squared, which is 3 plus lambda the whole squared, and this must be equal to 2 by square root of 3. I'll give you a few minutes. If I have this, simplify this so that I can find lambda. Take some time, do this. If you really solve for lambda, you will get lambda equals minus 7 by 2. Hence, you get that 5x minus 11y plus z minus 17 equal to 0 by plugging lambda equals minus 7 by 2.
Yeah.
All right. So I think we can stop at this point. I'll just leave you with a homework problem. Here's the problem statement. Suppose a plane passes through the point 1 minus 2, 1 and is perpendicular to two planes 2x minus 2y plus z equal to 0 and x minus y plus 2z equals 4. Then the distance of the plane from the point 1 to 2 is one of these. Try this problem and we'll pick up with the strategy to solve this problem and the visualization next time. Thank you.
Yeah. Thank you.